All right. This next part of the video is probably the most important part of the video that you're going to get for this section. And this is going to be the degree positions around what we call the unit circle. The unit circle is something that we'll talk about more as time goes on, but it's called a circle. You can tell that, obviously. Why is it called the unit circle? Well, the unit circle always has a radius that is equal to 1 unit. So that's why we call it the unit circle. And this is basically a foundation for most of the trigonometry that we're going to cover this semester. So that's why this is so very important. I'm going to walk you through how to count the degrees. Now you can just memorize these, which I do not recommend. I would recommend just learning how to count them out. And we're going to count around the circle in 2 different multiples. We'll count by 30s and we'll also count by 45s. The starting place is always the same. Remember in section 5.1, we talked about the angle in standard position. So we're always going to start on the positive x-axis because this is where my angle in standard position begins. And then we will most commonly rotate in a counterclockwise direction because this means that it's going to be a positive angle. So we are working in degrees here. Our very first angle is going to be 0 degrees. I'm going to work with each of these spokes that you see on the circle. Each of these spokes, well, actually, I'm not even going to say that. I'm going to let you figure that out. So let's go all the way around the circle. All the way around. If I go all the way around, how far have I gone? Well, you know that that's 360 degrees. So a 0 degree angle and a 360 degree angle are coterminal, or they land in the same spot. They have the same terminating spot. If I only go halfway around my circle, I know that this is going to be 180 degrees. If I only go this far around the circle, I know that this is going to be 90 degrees. And then if I decide to go, if I look at this first quadrant, notice that this first quadrant has 3 equal slices in it. If I take my 90 degrees and I split it into 3 equal slices, I know that each of those slices is going to be worth 30 degrees. So this is what we're going to do. Every spoke, every slice is worth 30 degrees. So we're going to count around the circle in 30-degree increments. So this first guy here, this is going to be 30 degrees. My next spoke, 60 degrees, because that's how we count, by 30s. The next spoke after that is 90. Makes sense. We already have that one. After 90, another 30 is going to be 120 degrees. We're only doing spokes here, only the slices. 30 degrees past 120 is going to be 150. 30 degrees past 150 is 180. 30 degrees past 180 is going to be 210. Another 30 degrees, it's going to be 240. Another 30 is going to be 270. Another 30, 300. 300 plus 30 is 330. And then I'm back to the beginning where I have 360. Okay, so now what I want us to do is we're not going to look at the spokes or the slices. What I want to do now is I want to pay attention to these points that are exactly halfway in the middle of each quadrant. And so you know that if you take 90 degrees and you split it exactly in half, you're going to get 45 degrees. So the exact middle spot is going to be 45 degrees. Well, if you take 45 and another 45, you're going to get 90. Okay, so that's great. Now add another 45 to that and you'll land right here. And that's going to give you 135. If you need to use your calculator to add another 45, you should get 180. If you're going to add another 45 to that, you're going to get 225. Add another 45 and you'll land down here at 270. It's a good way to check your work along the way. Add another 45 to that and you're going to get 315. add another 45, and you'll get back to 360. So this is going to be your degree positions around the circle. Now let's do the exact same thing for the radian positions around the circle. So first of all, you've got 0 radians. Now, I'll put radians for the first one, but I'm not going to put radians on all of them. Remember that the lack of a degree symbol, did I remember all of my degree symbols? The lack of a degree symbol is automatically a radian. Now, we know if we go all the way around the circle in radians that we have gone a distance of 2 pi radians. Well, think about what if we only go halfway around? Well, half of 2 pi is 1 pi. And then if you think of half of 1 pi, well, that's half of a pi. We don't write it 1/2 pi, we write it pi over 2. Now, this time, remember how with the degree positions, we split the first quadrant into 3 sections. And I could do that, but it's a little easier with this to take the whole entire top half. You see, I've got 6 equal slices, and I'm dividing up 1 whole pi into 6 equal slices. Well, that means that each slice is going to be worth 1/6 of a pi, or pi over 6. Okay, so what we're going to do now is we're just going to start counting around the circle in 6ths. Okay, so my first one here, this is 1 pi over 6. Well, that means that my next slice is going to be 2 pi over 6. But we're not going to leave it like that. Let's reduce our fraction. This is going to be pi over 3. But let's remember here, okay, so this is 1 pi over 6, 2 pi over 6. That makes this 3 pi over 6, but that makes sense. 3/6 is a half. What comes after 3 pi over 6? So the next piece is going to be 4 pi over 6. But we won't write that. We'll reduce our fraction to get 2 pi over 3. So that was 4 pi over 6. Next is going to be 5 pi over 6. After that will be 6 pi over 6. That makes sense. The next one, 7 pi over 6. After 7 pi over 6 is going to be 8 pi over 6, but that reduces to 4 pi over 3. 8 pi over 6 is going to be followed by 9 pi over 6. Reduce your fraction, 3 pi over 2. 9 pi over 6 gets followed by 10 pi over 6, which is 5 pi over 3. 10 pi over 6 gets followed by 11 pi over 6. Last but not least, after 11 pi over 6 is 12 pi over 6, and 12 pi over 6 reduces to 2 pi. Now, there's only one more set that we need, and that's going to be the smack dab in the middle spots. In the degree positions, those were those 45 degree positions. So if you'll think about the fact that pi over 2 is that whole entire quadrant, half of pi over 2, well, half of a half is 1/4. So this is going to be pi over 4. All right, so now let's count around the circle, just the midway spots, by fourths. So you have 1/4, 2/4. The next one will be 3/4. After 3/4 is 4/4. Then 5/4. After 5/4 is 6/4. That reduces to 3/2, so that's good. After 6/4 is 7/4. And after 7/4 is 8/4, and 8/4 reduces to 2 pi. You may need to watch this video, especially the parts with the unit circle on it, a couple of times. You need to become very familiar with being able to count around the unit circle, get very familiar with especially the radian positions, because you're going to be a little bit more fuzzy on the radian positions. You're a little more comfortable already with degree positions, because degrees are something that you're used to working with just in our natural world. So make sure that you are familiar with these.